Hello and welcome to the Chapter 6 podcast on Section 6.4. Today we're going to be talking about the wave behavior of matter. So, as we said before with Einstein and with some other people that we're going to talk about today, people began to realize that energy and light has dual properties. So, some things like light, for instance, have properties of particles as well as waves. So it has mass and it carries energy, but it also has wave-like characteristics as well. One of the other galvanizing principles for duality is Louis de Broglie's work on uncertainty. That's Heisenberg, but de Broglie was able to show, using his equation here, that mass could be related to the wavelength of a wave, and h is Planck's constant, and m is mass and v is velocity, but together they equal momentum. And this was another equation that was able to show that particles are waves and waves can be particles when we're talking about very, very small amounts of things. And this is something that's applicable not only to light, but also to electrons and all forms of matter. And this handsome gentleman is Louis de Broglie. This figure here on the bottom right represents the wave-like motion of the electrons around the nucleus. This is significant because one of Bohr's mistakes is that he thought the orbit around the nucleus was linear. And so once the wave-like orbits around the nucleus was realized, another piece of the puzzle kind of clicked in. Also, what you see here on the bottom is HIV entering a cell. This is an electron microscope picture. And so you know how you use light to focus, to see things, to magnify things in microscopes. Well, they were able to show that other waves could be focused the same way as light is. And so this is what happens when you use electrons in the same way light is focused in lenses for microscopes. So I talked about Heisenberg a little bit early, but this Heisenberg also explains some of the weirdness and limitations of this whole quantum theory. The dual nature of our waves and small particles limits their momentum and location. So in other words, you cannot know the velocity and the location for any particle at any given moment. You can know one, you can know the other one, but it's impossible to ever know both. And we'll talk a little bit about why that is in class. So if you feel a little bit confused, you're supposed to be. As the mass of the object increases, this impossibility starts to go down, and that's kind of what this equation above is meant to kind of show. And this was another big moment, another huge piece of the puzzle, because once people stopped trying to find snapshots of where electrons were, it became a little bit easier to understand its nature and the way it was working. And we'll talk a little bit more about why that is in class again. So that's it for now.